Hey everyone, welcome back. Today we are answering a question that drives beginners crazy. Why does Python have lists and tuples? I mean, look at them. They look almost identical. So why do we need two? Here is the uncomfortable truth. Python didn't create lists and tuples just to confuse you. It created them because your code breaks in subtle ways when data changes unexpectedly. And beginners hit those bugs all the time without realizing why. By the end of this video, you won't just know the difference. You'll understand why a list is like a whiteboard you can erase, and a tuple is like a statue carved in stone. Let's dive in. Let's start with the big picture. Python gives us two main paths for storing collections. On the left, we have the list. It is mutable. That is just fancy developer speak for changeable. It's active, flexible, and it can grow. On the right, we have the tuple. It is immutable, meaning unchangeable. It has a fixed size. Keep these two personalities in mind. One is flexible, the other is strict. I call these two the siblings because they share a lot of DNA. Look at the center. Both keep your data in order. Both use zero-based indexing, and both can hold a mix of strings, numbers, and booleans. But look at the outer edges. Lists use square brackets and change size. Tuples use parentheses and are locked. That syntax difference is your first big clue. Okay, look at this slide. This next line of code has wasted more beginner hours than almost anything else in Python. Creating a tuple usually uses parentheses, but look at the bottom right where it says critical. If you try to make a tuple with one item, like the number 2, and you write t equals open parenthesis 2 close parenthesis, Python gets confused. It interprets the parentheses as mathematical grouping, not a tuple. It thinks it's just an integer. The worst part? This mistake doesn't always fail immediately. Your code might run and break later, far away from where the bug actually is. To fix it, you must add a trailing comma. T equals, open parenthesis, 2, comma, close parenthesis. That comma is the secret signal that tells Python, this is a container, not a math equation. Here is the good news. If you can read a list, you can read a tuple. The patterns are identical. Square brackets grab an item. Index 0 gives you P. Index 1 gives you Y. And look at the bottom arrows. This is a cool trick. If you want the last item, don't count the length. Just ask for index -1. It wraps around to the end. This works for both siblings perfectly. All right, here is where the siblings stop getting along. This is the mutability test. Top example, we tell a list, A, change index 1 to 99. Python says, sure, and updates it. Bottom example, we try the exact same thing with a tuple, B. Type error. Now, I know what you're thinking. Why is Python being annoying? But listen closely. This isn't a bug, it's a feature. Python is choosing safety over convenience, and that's a trade-off you want. Tuples exist to stop accidental changes before they happen. Because lists are allowed to change, they come with a messy toolbox of superpowers. You can append to add items. You can remove items. You can sort them. Think of a list like a workbench. You can add tools, take them away, and rearrange everything. It's designed for work in progress. So if lists have all the cool tools, why use tuples? Tuples have a superpower called integrity. See those coordinates? 40.7, -74.0. You don't want those drifting by accident. A tuple locks them down. And here is the ultimate trust signal. Because tuples never change, they are hashable. That means you can use them as keys in a dictionary. If Python allows something to be a dictionary key, it means Python trusts it to never change. You cannot do that with a list. Let's peek under the hood at memory. Because lists need to grow, Python reserves extra empty seats in memory, just in case. It's called overallocation. Tuples are minimalists. They take up only the memory they need. If you look at the byte size, the tuple is physically smaller. It's leaner and lighter. That efficiency translates to speed. In this benchmark, looping through 100 million items was significantly faster with a tuple, about 12 seconds versus 16 seconds for a list. For small scripts, you won't notice this. But if you are processing massive datasets, tuples are your speed racer. Now for tuple magic. Look at example 2, the swap. In other languages, swapping two variables takes 3 lines of code. In Python, A, B equals B, A. That is actually tuple unpacking happening behind the scenes. And example 3, if a function returns 2 things, like a min and a max, Python automatically wraps them in a tuple. It makes your code incredibly clean. So, how do you decide? Choose a list if the data is dynamic. Do you need to add items later, sort, or filter? Use a list. If you're unsure, choose the one that matches your intent, not your habit. On the other hand, choose a tuple for static data, constants, configs, or records like name, age, job. If you ever pause and think, this value should never change, your hand should automatically reach for a tuple parenthesis. Here is the cheat sheet. Pause the video and screenshot this. Lists are mutable and slower. Tuples are immutable and faster. Simple as that. One last advanced puzzle. The Trojan horse. Can a tuple ever change? Technically, yes. If you put a list inside a tuple, you can modify that list. Think of it like a locked glass display case, the tuple. You can't take the items out, but if one of the items is an open notebook, the list, you can reach in and write a new page. In this code, T is locked, but T2 is a list, so we can append C. The container is locked, but the contents inside can still shift. To wrap up, start by using lists. They are flexible, but optimize your code by switching to tuples for anything that is write protected. That's how you write cleaner, faster, and safer Python. And there you have it. If this video changed how you think about lists and tuples, not just how you use them, then it did its job. If you found the comma trap or the Trojan horse helpful, let me know in the comments. Don't forget to like and subscribe for more Python tutorials that actually make sense. Happy coding, and I'll see you in the next one.